Hello and welcome back to the channel. Today is another day and here's another ECM to diagnose. Today we're going to be diagnosing a Bosch MaxxForce 13 from a 2014 Paystar. This is a Navistar ECM. We're going to be using a DPA5 again. I like using the DPA5 because it is great for logging data. And we're also going to be using this here Bosch breakout connector for the Navistar ECM. I'll just connect that up. There we go. So we have everything connected. We're starting to draw 0.58 amps. So we're just about ready to get started. So let's get the software running. Okay, we'll start up PFD-Tool. And here we go. Now we check to make sure we're using the DPA5 Pro, USB ID2, and the protocol we're going to be using is MaxxForce Navistar. And that's what we have. Now, the parameters at the top here, you'll see 110, 100, 158. These are J1939 parameters, so we go to the J1939 list and select our parameters here. These parameters are numbered from 20 all the way up to 8,074. So you select the parameters that you want. On the right side, there's a push pin. If you want to chart that parameter on the chart over here, you just click on the push pin and that'll chart the data. And you have a checkbox here. Checkbox on indicates that that parameter is going to be monitored. Again, the fewer the parameters, the better. So only select parameters that you require to do the diagnostics. Don't be selecting a whole whack of parameters because it's just going to slow you down if you don't need them. And next, we're going to select Navistar parameters. And Navistar parameters start at 41,000 and go up to 99,550. These are OEM parameters, so these are the same parameters that you will find listed in NEDS. NEDS is the Navistar diagnostic software, and these parameters here are the same parameters you'll see on NEDS, and I can show you that here. So we have 57051. So we'll bring up the NED sheet, find it, and there we are, 5701. Okay, and again, the push pin on the side here, and as with the J1939, the fewer the parameters, the better. So we have our parameters selected. We have our graphed parameters selected. We have our protocol and adapter. So time to connect. And there we're connected. There's the VIN number, and it's reading the data plate now, filling out the OEM information. And there we go. Now we have a couple of buttons that appeared up here. This first one in the green here is a parameter editing. That allows you to go in and edit a parameter. So if you turn that on, it allows you to make changes to parameters. You see now I can edit this box and change the VIN number. Once I make the changes, I select the button over here, program the selected parameter, and it will write that parameter to the ECM. I don't want to change the VIN number, so I'm going to turn that back off. And then over here you have chart selected parameter. So for example, engine coolant temperature, I can select that. and then hit this switch and it'll bring up a high resolution graph for engine coolant temperature to get a more dynamic or closer look at any variations in the data. So it could be a bad wire or a bad sensor or something of that nature. It'll give me a much higher resolution on the graph. If you want to know more about the graph, take a look at our video on PFD-Tool and the features. Then we have run tests. For Navistar, we have 5 tests. Yeah, 5. DPF regen, cylinder cutout, fuel actuator, DPF service and replace, and injector quantity adjustment. We're going to be adding more, of course, and as we add more, they will be free. We never charge for updates or upgrades. And let's have a look at injector quantity adjustment. When you put a new injector in an engine, there's a barcode or a number on the side of the injector, and that's the test from the factory for the quantity that the injector injects every time it strokes. And that adjustment can be entered to the ECM. There's a little warning there. And it tells the ECM what the quantity measurement is, and it's in a hexadecimal code. And what you do is, depending on which injector you've changed, you go in here, and if you have made a change here, say instead of 6C, it was a 7C, then you'll get a check mark when you leave that. To enter that into the engine, you just hit program, and it will program that in. I'm going to cancel. The next test to have a quick look at, cylinder cutout. Okay, another just generic warnings. On here you have, on the right side, you have automatic cylinder cutouts, and on the left you have manual. So the engine is not, of course, hooked up, and therefore there's nothing to test, but we have it set as a demo if there's no engine detected. So you'll see the demo running here. If there was an actual engine hooked up and running, then this data would be the actual data from the engine. And then you can manually turn off each injector by clicking the switch. You see it turns red. That injector's off, and hopefully there will be a change in the engine vibrations and that sort of thing, in the RPM. Switch it back on. You can turn off multiple. You can turn them all off if you want, but the engine will stall. I've had engines run on one cylinder, and they're quite lumpy, but they do run. And then over here is automatic. You hit start, and what the program will do is it will monitor the engine for a period of time to get a baseline. Once it has the baseline, there we go, it will start cutting out cylinders. And here it's going to do 1, 2, 3, and then 1, 2, 4, and then 1, 2, 5, and then 1, 2, 6, and so on in a specific pattern until it's completed all cylinders. It'll put the data in this chart here. Now, keep in mind, this is a demo, so the data is all random. So you're going to get really bizarre results, I suppose you could say. So there we go again. 135, 136. And as it's doing this, it's charting the effect of that cylinder being cut out. 1, 4, 5. So those are the cylinders there. You see them listed in the chart here in the legend. And you haven't seen anything over here in the cylinder results because the actual results have not been calculated yet. They're going into this chart here, and this chart will be used to do the calculation once it's full. So we're 50% done. We moved up to 2, 3, 4. So cylinder 1 will not be cut out from now on. And then we're going to 2, 3, 6. And then we'll go to 3, 4, 5. And when we go to 3, 4, 5, cylinder 2 will remain on for the rest of the test. Two, 4, 6, 2, 5, 6. And then we'll go 3, 4, 5. There we go. So cylinder 2 will no longer be cut out. It will remain on for the rest of the test. We're 80% complete. And then it'll go 4, 5, 6, and we're done. There we go. And you'll see the chart will fill in here, and then we'll get our results. There. So according to this test, cylinders 5 and 6 are the weakest, followed by 4, and cylinders 1, 2, and 3 are fine. They're up there in the high end. And that's a cylinder cutout test on a MaxxForce 13. So as you can see, there's a lot of functionality, and there's going to be more coming. We have fault code, delete, view, delete, and print DTC reports. This is what a DTC report looks like. And this is what it looks like when you just view them on the screen here. And if you hover over, if there are freeze frames, you'll see them come up. And this one here says that there are no freeze frames available for that protocol or for that parameter. And you'll see the engine, the SPN, the FMI, and how many times the count for that fault has occurred. Cancel. Then you could go in and print those DTCs. We're going to just print it to a PDF. We'll give it a name. Just give it a quick name here. So that's it for PFD-Tool testing on a MaxxForce 13. We hope you enjoyed this quick little demonstration, and we look forward to seeing you next time when we test another ECM on another day.